Hey there, everyone. So I think you can see from the title of this that the topic for today's lesson is going to be factoring quadratics with a chart. In the last video, we learned how to factor quadratics using diamond problems and a generic rectangle. And this is a different method. This one's not taught in your CPM book, but this is a method that is commonly used. And I think it's a little quicker than doing the diamond and generic rectangle, but they both have their plus sides. So I'm going to show you the first problem just using the chart method, and then problems 2, 3, and 4, I'm going to show you using both methods, and you can see how they sort of go together. Okay, so if you're using a chart, the chart really just has a top and a bottom. All right, and here's how you figure it out. The top part is factors of the first term, and the bottom part is factors of the third term. All right, so you can see the only factors I have for x squared would be x times x. And then for 15, I have 1 and 15, and then 3 and 5. And that's it. All right. By the way, when I'm doing the factors, I go right in order. I just start with 1, and 1 and whatever the number is will always be your first one. And I'm like 2, nope, 3, yep, 3 and 5, 4, nope. And then once you hit a number that you've had before, you're done. Right, so I know these are all of the possible factors. Okay, so that's the first step. Okay, the second step is to look for combinations of products that will result in the sum of the middle number. So I want to say this first. This is sum because in front of the 15 there is a positive. Excuse me. If this were a minus sign or a negative, you'd be looking for a difference, and I'll show you one like that in a bit. Okay, so what you do is you can find patterns either on the outside of the chart like this, or across the middle on the inside like this. Right now, in this case, since these top two terms are the same, it's not going to matter. But here's what I've decided. All right, 5 times x is 5x, 3 times x is 3x. There are my products. The sum of those products is 8x. So that's what I want, all right? 15x plus 1x is 16x. That's not it. All right, so I know what I want to use. I want to use this. Of course, that's the only thing. And then from the bottom, I want to use these two. You can't use like one here and like this one here. You have to use the same row because the product of these two has to be 15. All right, hopefully that makes sense. All right, and then step 3. First of all, see how I wrote FOIL here? All right, so this is just a mnemonic device that we used. Firsts, outers, inners, last. Well, this becomes useful again here because one set of numbers will be your inners and another will be your outers. So remember I said one set is going to be 5 and x, another one is going to be 3 and x. So I decided 5 and x will be my outers, so x here and positive 5 here, and x and 3 would be my inners. Right? It doesn't really matter. If you had gone the other way around, you would have had just x plus 5 first times x plus 3. That's going to be the same. All right, so that's really the process. All right, let's go through a few more here, and I did these out on paper. All right, so I'll try to point out what I did. Okay, but for the chart method, all right, for example 2, I have 6x squared plus 17x plus 12, and I want to factor that into 2 binomials. All right, so I'm getting for the top part, factors of the first term, for the bottom part, factors of the third term. So again, I'm starting with 1, but remember we don't need that, but x times 6x, perfect. And then, yeah, 2 times 3, so 2x and 3x, done there. And then 4, 12, okay, 1 and 12, and then 2 times 6, at 3 times 4, and then I'm right back at 4. So there's my chart, right? I've set that up. This is still a positive, so I'm still looking for a sum. And I'm always looking for the middle number, no matter what. So I'm looking for a sum of 17. So I decided when I did this, I did a lot of multiplying and that type of thing. And then I landed on 2x times 4 is 8x. 3 times 3x is 9x. And 8x plus 9x is 17x. So that's what I want. And one will be my inners, one will be my outers. Again, it doesn't matter which. So I decided 2x and 4 are my inners. 3x and 3 are my outers. That's my answer right there. All right, so let's see how that compares to the diamond and rectangle method. So for the diamond and rectangle method, I started by writing my first and third terms right here, 6x squared and 12. All right, and then over here I made my diamond. All right, so I found the product of the first and third, which is 72x squared. Right, and then my sum, which is the middle number here, 17x. All right, so once I wrote those, I'm like, okay, what are some factors of 72 that will add up to 17? 8 and 9. So then next step, you write in your 8x and 9x, so it doesn't matter where those go. And then you find the outside. So I started right here with the 6x squared and 9x. The common factor there is 3 and then x. So I wrote that here, and then from there I found my 2x, because 3x times 2x gives you 6x squared. And then from there I was able to find this one here, because 2x times 4 is 8x. And then from there I needed to get 12, and I know 4 times 3 is 12, so that had to be 3, and it works here as well. All right, for this though, each one is a set of parentheses, so I put this one here, 2x plus 3, and then 3x plus 4. And then you can see this is the same answer. It does not matter that they're written in different orders. These two are the same thing, right? So this one's using the chart method. This one's using the diamond and rectangle method. Okay, this is the first one where you're looking for a difference. All right, so when you're working with the chart, that becomes really important. And you're looking for a difference of negative 7x. Again, you're always looking for the middle no matter what. Whether it's a sum or difference, you're looking for the middle. So I started with my chart. I didn't even worry about my signs yet. So x and 2x for my first term, 1 and 15 and 3 and 5. Okay, now this time I'm looking for a difference of 7. So I'm like, okay, 10 and 3. 10 minus 3 is 7. Okay, but then since I'm looking for a negative, I always opt to put my signs down here. I want my 10x to be negative, so I want to be doing 2x times negative 5. And then this would be positive. By the way, if you're looking for a difference, one of these will be positive and the other will be negative. All right, so my pattern's on the outside this time, so I decided these would be my inners. Note I'm always putting the variable first, right? That's a good idea when you're doing this, all right? Because if you had put the 3 here, that would be incorrect, right? So x and 3 would be my inners, and then 2x and negative 5 are my outers. Right, now in terms of the generic rectangle and diamond, I started here with my first and third terms, right? Then I came over here for my diamond, so I multiplied the first and third terms to get negative 30x. Okay, and then I wrote my sum here, negative 7x. So now I'm looking for two factors that make a product of negative 30x squared, and they have a sum of negative 7x. So I landed on 3 and 10, right? Because as long as this is negative, that's going to result in a sum of negative, right? So 3 and negative 10x doesn't matter where you write it. I decided to go across this way first because the only thing they have in common is x. That automatically makes this 2x. Once I knew that, I knew this had to be negative 5. And once I knew that, I knew this needed to be 3. All right, so then I've got x minus 5 on one side, 2x plus 3 on the other. And again, you can see it's the same. All right, last one. All right, this time I'm looking for a sum because this is positive. This time, though, I'm looking for a sum of negative 17. All right, so I'll show you what that looks like. So first I found my factors, so x and 6x, 2x and 3x, that's my first term. And then for 5, I only have one possibility, 1 and 5. All right, this time, since I'm looking for a sum of negative 17, both of these need to be negative. So I want a negative 15 combined with a negative 2. All right, so negative 2x and negative 15x gives you negative 17x. And then the 3x and negative 5 are my outers, and then my 2x and negative 1 are my inners. Again, if you just put your term with the variable first and your constant second, that will help you avoid mistakes there. All right, let's see how it compares to the diamond and rectangle. You can see already I got the same answer, all right, but again, here's the process here. First term and third term right here. Then multiply those together. All right, so I write first and third, multiply them together, put that here. write the middle term here. Now I'm looking for something that gives me a product of 30x squared, but also gives me a sum of negative 17x. So I'm like, this has to be positive. If this has to be negative, they both have to be negative. I'm like, oh, 2 times 15, that's 17. Just make them both negative, right? Put them anywhere. I put the negative 2x here, negative 15x here. I like to start with my x's because that I just find that a little bit easier. So I went this way first, right? So I always keep the x term positive. So if there's a negative, just keep your x term positive to begin with. So 3 and x goes into both of these. Once I got that one, I got this as 2x because 3x times 2x gives you 6x squared. Once I had that, this had to be negative 1 because it's just the opposite of that. And then since this has to be positive 5, this had to be negative 5, and then it works there. And you can see, all right, I've got 2x minus 5 up here. That got cut off a little bit, but 2x minus 5 here times 3x minus 1 here. And that really is the same answer. All right, so I'm hoping I've given you another way to do this. What I'm going to ask you to do today is I'm going to have you take that quiz where you're going to factor a few quadratics, and you can do it however you want to, and then we'll see how that goes. Okay, I'm hoping this is making sense, everybody. Nice job.